Hi, welcome to the dynamics tutorials. So in this case we're going to do, again, Newton's equations or equations of motion with rectilinear coordinates, and we're looking again at kinetics. So how we're going to get accelerations from forces or vice versa. And at this one we've got a pulley problem, so we also have related rates on top of it. So we have 15 kilogram mass at A and a 20 kilogram mass at B, connected through this pulley arrangement. It's initially at rest and then we're releasing it. So we want to find out the acceleration of mass B and then also the speed of mass B after 1 second of motion. So we'll need to relate the motions of A and B together. So let's look at what's moving in our pulley system, what's potentially moving up and down in our pulley system. So this pulley here can translate, so we're going to mark it with the distance. We'll call it SA because it's connected to mass A. And then this mass over here can translate, so we're going to mark it with an SB because this is mass B. These two pulleys are fixed in their distance to the ceiling here, and so we don't have to track their distances because those will always be the same. Looking at SA, we have 1, 2, 3 things that depend on that distance, and with SB we just have the one thing that depends on that distance. So our equation is that the length of rope is going to be equal to 3 times SA plus SB plus or minus some constant material for the links not going all the way and some little bit of rope that remains on the pulleys. So now we can take our time derivative of length and we'll get dl dt is equal to 0, and then that'll give us 3 times dsa dt plus dsb dt. And remember that we can write the d dt's as just the quantity, the variable with the dot on top of it. So this will be 3sa dot plus sb dot. Then we can take a second derivative. So remember, the second derivative has with respect to time, has 2 dots over top of it. So it would be 3sa double dot plus sb double dot equals 0. And so solving for sa, we get sa is equal to negative 1/3 sb double dot and sb double dot. Now we need to relate this to the accelerations. So we could see that the accelerations are going to have the same relation. If we look at SA, when SA is increasing, we're moving down. So that would be as if we're putting a negative sign in here and substituting AA for SA dot, double dot. And then when we're looking at B, if SB is increasing, we're moving down. So that would be the same thing as putting a negative in here and substituting AB for SB double dot. But you can see that those negatives are just going to cancel out, and you'll get that acceleration A is equal to 1/3 the acceleration of B. Now we're ready to do our 2 free body diagrams. So free body diagram for A. When we're disconnecting A, we're having to cut through 1, 2, 3 ropes. So we're going to have 3 tensions acting on A, and then we'll have its weight acting down. And then with our sum of forces, we'll have that's equal to the mass of A times the acceleration of A in the y direction. So we'll have 3t minus the weight is equal to the mass, 15 kilograms, times acceleration of A. And then for our free body diagram at B, we're only having to cut through 1 rope to separate B out, so we just have the single tension going up, and then we have the weight coming down. So doing sum of forces in the y is going to be equal then to the mass of B, which is our 20 kilograms, times the acceleration of B in the y. And then on our other side, we'll just have T going up, and then the weight coming down. We could solve this equation for T just because it's a little simpler than this one, just because you only have the 1T and you have the 3 T's here. Then you could substitute this for T into here. So you'll end up with 3 times 20 kilograms times AB plus the 196 newtons that you had there, minus the 147 newtons that you brought down from this equation is equal to the 15 kilograms times acceleration for A. Let's go ahead and make this substitution and do minus 1/3 AB in there. Then we just collect all of the terms and we get 65 kilograms times AB is equal to negative 441 newtons, and we could solve for AB and we get that it's negative 6.79 meters per second squared. In other words, B is moving down with that acceleration. That's a constant acceleration, so we can use our integrated equation for velocity. We're looking at acceleration, velocity, and time. So we need this equation relating velocity, acceleration, and time together, and plug it all in, and we get VB then is equal to initial velocity of 0 because it's starting from rest, plus that acceleration times the 1 second, and we get the same negative 6.97 meters per second. So that means that B is moving down after the 1 second. Thanks for watching.